Okay, welcome Year 12s to this next video. What I'm going to do in this one is take you through simple interest. So some of you might have heard of interest before. You probably hear sometimes on the news them talk about interest rates, or you might have a savings account so you know what interest is, because every month you might have a little bit extra added to your account. And that bit that's added is called the interest. So there's a couple of different sort of ways that we can look at interest. One is from an investment point of view, and that is when you are earning interest. The most common example of that would be a savings account, but there are other examples. And the other type of interest, which is the nasty one, that's from when you take out a loan. So if you say go to a bank and ask them to have them lend you $1,000, when you pay back that money, you don't just pay back the $1,000 you borrowed. You actually have to pay back a little bit more, and that's a charge. It's a charge that the bank will impose on you for borrowing that money. And that charge is called interest as well. So interest can be from borrowing, or it can be from investing. So what I'm going to do is take you through the most basic form of interest, and that's called simple interest. Now, simple interest is calculated just on the principal. The principal is the initial amount that you've borrowed or invested. So if I say go to that bank and I ask for $1,000, the principal would be $1,000. That's the amount that I have borrowed at the start. Or if I open a savings account and say I put $1,000 in that, the principal again is $1,000 because that's the initial amount that I have put into the account. The other things that we need to look at, obviously I is for interest, so in this case it's simple interest. The R in here, it is actually R over 100, and the reason for that is R is the interest rate, and that is given as a percentage, and quite often you'll see it written like this with percentage P dot A, and that means per annum. Per annum is another way of saying per year. So the rate will be given as a percentage per year, and we just take the R value, so we just take the percentage value and we put it into the formula here. The final thing we need to calculate simple interest is the time or the length of the loan. So this could be the length of, obviously, however long you've been given to pay back a loan, or it could be also the amount of years, say, that you had money in your account. So what this is actually doing is, just say I had $1,000 in the bank, and I then had an interest rate, I don't know, just make something up, 5%, and I just had that in for 1 year. What we can do with the simple interest formula is we can calculate here how much we would earn in that 1 year. With 5% interest for 1 year, with a principal of $1,000, how much would that give us? Well, that's going to be $50. So what we can do is any amount of time, any interest rate, any principal. That's where this formula is going to be quite useful, and you are going to use this formula a lot. One thing that we do need to be careful of first is that I mentioned that the rate will most likely be given in per annum, but sometimes they're tricky and they might give you the percentage per month. Now, if they do that, if they do give you the percentage per month, then just make sure that your time is also in months. So if they said, look, it's 2% per month for 1 year, you'd then have to change your time value to 12, so that you're working with 12 months and a rate per month as well. Likewise, if you're given the percentage in per day, which is rare, but it can happen, make sure your time is also in days. Now, obviously, we can rearrange this interest formula. Therefore, we can find, for example, the principal, we can find the rate, or we can find the time period of a loan or an investment. So because we have a calculator that does solve, there's no need to rearrange. We can just substitute values into this rule, and whatever's unknown, we can solve for that. So we'll do a couple of problems in a moment where we have to do that. Another thing that we need to investigate is this part here, which is actually, if you're actually finding the final amount of the loan, or if you're looking at the final, say, value on your savings account after a period of time. And the letter that we assign to that is called A. So just think A for amount or total amount. So to get the total amount, say, from a savings account, we'd take the principal, so we take whatever you put into the savings account at the start, and we would add on any interest that you have accrued in that period. So it would be amount is equal to principal plus interest. I'll write that out in full. But this is something that we'll use throughout this business module, knowing that the final amount that you're left with, it might be how much you need to pay after a loan, or it could be from an investment. Obviously, the total amount must include the interest payment. So we just add that to our principal. Now, if I know that interest is PRT over 100 and I actually substitute this bit here into that rule, what I get is the formula below that, so this one here. This is saying that the final amount is equal to the principal plus PRT over 100. So it's just another way of extending the one before it, and you would use this one if you, say, were asked for the final amount and you had the principal, the rate, and the time. Obviously, you could use this formula and then substitute it into that one there. That's fine as well, but this is sort of doing two steps in one. Now, obviously, if you were given this one here and say you were given the final amount, you were given the rate and the time, you could then solve for P. You could solve for the principal. You could find how much was put in at the start or how much was borrowed at the start. Now, graphically, the simple interest graph will look familiar to you, will look like a graph that you have come across before. Because the simple interest formula, when we look at it, every single year we actually have the same percentage being added on to our principal. So what that is effectively is a constant rate. It's a constant rate every single year going up by the same amount. And when you graph that, you would know that a constant rate means constant gradient. That's a straight line. So what we have when we graph interest against time is a straight line. Now it should go through the origin here because before any time has passed, you have not paid or earned any interest. Now if I instead wanted to graph, say, the final amount, oops, that's not a straight line. If I wanted to graph, say, the final amount A over time, my graph might look a little bit more like this. And the reason for that is my starting amount won't be zero. My starting amount could perhaps be, say, $1,000. Whatever this starting amount is here, that's my principal just there. The y-intercept would be the principal. And as we can see, each time we increase by, say, oops, each time we increase by perhaps 1 year, we should see that we're rising, or the amount is rising by the same amount for each increment of time. So on a graph, it does look like a straight line, which is a little bit different to, or it's quite different in fact, to the next type of interest that we look at, which is called compound interest. Let's do some examples though for simple interest so that we get used to this formula. And you are going to use this formula so much that it will start to be ingrained in your memory. I is equal to PRT over 100. Let's first list the information that we have and just check on what we are asked to find. How much interest would be earned? So obviously we are trying to find I. It's good to jot down the information you've got on the side. You've invested $5,000, so that's our principal. The rate is 15% per annum, so R is equal to 15, and the time period here is 4 years. So you can check your time, it's in years, and the rate is per annum, so that works. Remember, we want them to be in the same time unit. Let's substitute now into this formula. And finally, we have $3,000. Okay. Next one. How much interest would you earn if you invested $5,000? So again, $5,000 at a rate of 15% per annum, but this time a shorter time period for 18 months. Now remember, if your rate is in per annum, so per year, you also need your time in years. At the moment, it's not in years, it's in months. So to convert this, what we can do is go, all right, 18 months divided by 12 months in a year, that's 1.5 years. Let's now do our simple interest formula. I is equal to PRT over 100. That's 5,000 by 15 by 1.5 over 100. And what you should get when you do that is 1,125. Okay, this one down here is a little bit different. What we can see here is we've got a rate of 9% simple interest on an investment. We've got 4 years, so there's our time. But this time we've been given the interest. The interest is $215. It says here, find the initial amount invested. The initial amount, remember, is P, the principal. So that's what we're trying to find in this example. R is 9%. T is 4. Check your rate. Again, it's per annum, and we are in years, so this works out. I is equal to PRT over 100. Substitute your values in. 215 is equal to P by 9 by 4 over 100, and P, therefore, when you use solve, you should get 597.22. Always rounding to 2 decimal places, please, because we are dealing with finance, we are dealing with money, and obviously we usually round to 2 decimal places to represent the cents. Okay, over the page now, if we have a look at this example here, it's asked us to find the total amount owed. So remember, total amount is not I is interest. Total amount is asking us to find A. How much altogether is owed on this loan? So how much altogether are you going to have to pay back? So you've borrowed $10,000, perhaps this is for a car, or something like that. The rate is 12% per annum, it's simple interest, and we're looking at 12 years, the end of 12 years. It's quite a long time. Okay, so A I'll do over here, and I'll leave a little bit of space for B. Finding the total amount, we can use this formula. Oops, that should be P. So we've got principal here, we've got the rate, and we've got the time over here. We've got P, R, and T. Therefore, this is 10,000 plus 10,000 times by the rate, 12%, times by the time, which is 12 years, over 100. This scenario is a little bit unlikely, because A, the interest rate is really high, 12% is quite high, but also for a $10,000 loan, you'd probably want to pay that back in less than 12 years. That's quite a long time to have a loan, unless of course it's a mortgage. So $24,400 is how much you would owe after that 12 years. So that's including the $10,000 that you originally borrowed. You can see here why it's important to pay back loans as soon as possible. Otherwise, the interest is obviously going to cost you a lot more. Now, B is saying represent this graphically just on the calculator. So I'm going to do that in a moment. But what I'm going to do first is just show you that the formula that I'm putting into the calculator, and your calculator will have F1 of X. You'll see that when I open the calculator up. What we do is we express it in terms of T, in terms of the time. So what I'll do is I'll rewrite what I had over here, which was principal plus PRT over 100. I'm going to put this into my calculator, but obviously instead of T, I might change that actually, because your calculator deals with X's on the horizontal axis, not with T's. So what I'm going to do is type this into the calculator. We're going to have a look at it graphically. And obviously we're expecting a straight line, aren't we? Because I did warn you earlier that that's what the simple interest graph looks like. So I'll just put this up so that we can see it quite clearly. Okay, 12 times X, and that's over 100. And I accidentally, there, that's better. Okay, now when I press enter on this, I'm not going to be able to see the graph, or I can sort of see it, but it doesn't look really good to me at the moment. One reason is I'm looking at negatives and we don't deal with negative time, and also the example I had before went up to 12 years. So really I want to have a look at X between 0 and 12. I also know that the total amount when X was 12 was 24,000, and if you look at this scale, it only goes up to 6.67, which really just won't do for us with this question. So let's go to window and window settings. We'll go to X minimum, say, I'll just go -1 just so that we can see the axis, and I'll go up to where X is, say, 13, so I can see beyond that 12th year. Now, we're not going to have a negative amount, are we? Because the amount really started at 10,000. But look, I'll go from 0. And the maximum, I'm going to have a look at about 30,000. Now, when I do that, here we go. Here's our straight line graph. We can see at the start over here, that's when before any time has passed, we would have a y-intercept here of 10,000. So that's where the amount starts off at. Now what I can do is have a look at what's happening. If I go to trace, what's happening after 1 year, for example. If you have a look down here, it will use scientific notation, so that's a little bit annoying for me showing you this, but every time I move across the graph, what we should see is it is increasing by the same amount. So have a look, it is going up by the same amount each time. And finally, when we get to 12, I'll skip to 12, which is what we just calculated, there's our 24,400. So don't forget this scientific notation, that just means 2.44 times 10 to the power of 4. So just move your decimal point 4 times to the right. You don't really need to graph these often. You might be asked to, say, interpret a graph, and there might be a question where it's asked you just to pop it into your calculator and have a look at the graph. So for that reason, we've done an example on that now. What I'm going to do is just a really, really quick sketch of it, and I'll show you how we do that. It's a little bit difficult freehand, as you can see. But basically, we're starting off at I do apologise for the barking dog. Here's our final amount on the y-axis, the time on the x-axis. It starts off at $10,000, and over at where time was 12, we calculated that over here. The A value, the total amount, was 24,400. So if that's 10,000, that's 20, about halfway. And then down there. And you can label that. Just get rid of that. You can label this point here. This one here would be 24,400. And I've just got that from my calculations over there on the left for A. Okay. What I'm going to do now is a different question. This is one where we are going to have to use solve. what we've got here is Andrew's investment realised a total amount. It means that it reached a total amount of $25,000. So your A value has gone up to $25,000. After 5 years, that's the time. Simple interest of 5.6%. Now, if it doesn't mention it, we can assume that that is per annum. Find the initial amount invested. It's asked us to find the principal. We do have a formula that links all of these things, and I've just done the same thing I did before. That's better. The final amount is equal to P plus PRT over 100. We've got that final amount. So let's substitute that into the rule. I don't know P, so that's going to stay like that. The rate is 5.6. The time is 5 years, and that must be over 100. Let's solve for P. And when you do that and round to 2 decimal places, what you should find is this investment, the original investment, was $19,531.25. So this was originally invested, and after 5 years, it grew to $25,000. So just by having it sitting in the investment, might be in a savings account, could be in, say, a term deposit, whatever it is, we can see that there's been quite a considerable amount of interest earned in those 5 years. Okay, so what I'd like you to do now is to have a look at these questions just below. So exercise 20B. It is. There's a few there, but a lot of these questions are just getting you used to using the simple interest formula and using it not only just to find I, but to find, say, the principal, the rate, and the time period as well. So thanks very much for listening, and I will see you in class next time.